Good evening everyone. Today we are going to do the daily Leetcode challenge of 5 March 2023. That is question number 1345. Jump game 4. It is a hard question, but is this question will be easy or medium for you if you watch the video carefully. So let's move on. The question is saying that we are given an array of integers. We can move one step ahead or one step below, but we cannot exceed the array length, and if the values are same we can directly jump to that index. That is what they are saying, and we have to reach the last index in the minimum number of steps. So without wasting any time, let's move on to the example. So in the first example, what we can do, we have indexes 0 1 2 3 4 5 6 7 8 and 9. We have to reach the ninth index. So starting from 0, we have choice to move here. We cannot move behind, but we can also move to up to 4. So we move from 100. Let's write the indexes 0 to 1 or 0 to 4. Let's say we move to 0 to 4. From here we have the choice to move from 4 to 5. And from here we can directly move to 7, that is same value. So we move here, and after that we can move directly to, we can move to 3, that is 8th index, and finally we can move to 9th. So number of steps will be 1, 2, 3, 4, 5. But is it optimal? So from 4, what we can do, we can move one step behind as well. So we move to 3rd index, and this value is same as 9th, so we can move directly to 9. So how many steps did we took? We took 1, 2 and 3 steps, and that is our answer. So how do we approach this question? Please think around it, think of some different test case and then come back to the video. So I hope you tried the question. To solve this question, let's move on here. So what we can actually do is, when we have given 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9th indexes, what we can do, we can make a hash map. Inside the hash map, for every value, for 100 value, where it is stored. It is stored at 0 and it is stored at 4th index. So we can store that value. And then after that we have minus 23. It is stored at 1 index, 2 index. Then we have 404. It is stored at 3rd index and it is stored at 9th index. Then we have 100 again, which is already stored. Then we have 23, and 23 is stored at 5, 6, 7. So we will store that. And then we have 3, which is at 8th value. So this way we can store them in a map. Now when you see this, that is when at 0 you have two choices, or you can say three type of choices. One is I plus 1, that is first index. At 0 index we cannot go back, so there is no option, but we have the option to go at the same value. So it is at 0 itself, and the other option is 4, so we can directly go to 4. Now when you come to 1, you have again two choices. You can go to 2, you can go to its previous value, that is 0, or you can go to its same value, that is also 2 in this case. But when you come to 4, you have again two choices, that is one is 5 forward, then one is 3 backward, and 0 is already done, so you won't write it again. But when you come to 3, you can see that 3 has another choices, that is 2, and it has choice to go to 9. That is the same value. Yes or no? And 3 is already done. So when you see this, you can see it is forming a tree-like structure. And when it is in a tree, the best way to get the minimum number of steps is BFS, breadth first search. So we simply apply the breadth first search and we can get it. And when we are applying the BFS call again, we don't want the value to repeat in our queue and stack. For BFS, we make a queue and we make a visited array. Visited array will make sure that we only visit one element once, and queue will iterate through all the elements. And inside the queue, what we will push? We will push I plus 1 element, I minus 1 element, and the values from the map. And when we have pushed the values from the map, so let's say 0 and 4 is pushed, then when you again come to this 3rd index, the 4 will repeat if you haven't cleared it. So after every iteration you will clear this value. So that is all you have to do. The main concept here was to see that it is forming a tree like structure, and you have to apply BFS. For BFS, you can check out my previous videos or reference any other videos from any other creator. Now let's move on to the code, and I will tell you the implementation of BFS there. Also, you can comment down if you want me to explain the BFS dry run of this question. The only concept here was to see that it is forming a graph-like structure. Then implementing BFS is always the same. All you need to know about BFS. You can refer my other videos for that as well. Now let's move on with the code. Now what we can do, we can initialize int n is equal to array dot size. That will give us the array size. Now we will make a unordered map of value int and a vector int. Let's name it as map. And after that we will push the values I0, I less than n, I plus plus, and we will push the indexes at the values and make a graph like this, map like this. Every value will have stored index. For that you will write map array I dot push back I. This will push values inside the map. Now after that what you have to do, you will apply a queue, that is BFS call. So for BFS what you know, you make a queue int, let's name it as queue. You make a visited array, boolean array, let's name it visited, it should be vector. We make a visited boolean array, and after that we make first index, that is 0 to true, and we push the 0th index to our queue. After that, actual BFS call, what is happening, that is while queue is not empty, we will run it. Now we will get the size of the queue, that is queue dot size. After that, when this size is enough, that is whenever this size is there, we will implement int x is equal to queue dot front, and we will pop the front element in a BFS call. When we have popped the front element, what we will do, we will check if this x is equal to n minus 1, that is we have reached the last index, we will return our steps. So we also have to make a variable int steps to store our number of steps. After that we will check for int j2, let's say map arr x, that is the index stored value. We are storing these values and we are checking whether it is there in the queue or we have to push it. Whenever we are visiting them first time, we have to push it, so we will simply push them in our queue and mark them as visited. And after we have checked for the indexes, what are the other two conditions we have to check? We have to check if x plus 1 is less than n and x and it is not visited, that is x plus 1 value is not visited. Then what we have to do, we have to push x plus 1 in our queue and we will mark it as visited is equal to true. And if this is not the case, if x plus, and the other case is if x minus 1 is greater than or equal to 0 and it is not visited, then we push it to our queue and we mark it as visited. So that's all you have to do. And after this call, as I told you that we will have to clear the map, so we will clear it as well. We will clear it for that value, so we do not iterate again for the same value. Okay, and after this is done, you will increase the number of steps after every BFS call, and finally you will return the number of steps you have taken. So let's just run and check whether it is working or not. What is, oh, it should not be I, it should be X. Another error, runtime error, not assigned. Oh, we haven't declared the size of this visited array. Let's run it again. We are getting wrong answer. Why? Because we have written x here. It should be j because we are iterating for its elements, right? So in a loop we are iterating for these points 1 and 2, 3 and 9, 5, 6, 7. So it should be j and j should be made true. Now it should work. Let's see. So yeah, it is running. Let's just submit it. So yeah, it is accepted as well. So the time complexity of BFS in this case will be O of n and the space complexity is also O of n. I hope you liked the video. Please like, share and subscribe. Thank you so much for watching. Bye bye.